Again, a which is not is it's a tricky equation or a tricky question. Key thing, and this is a great question because um, you got 1, 2, 3, 4, 5 terms, and from 1 to 5, that's pretty straightforward. You might look at this and say, okay, it's increasing by 4, but it doesn't necessarily start at -1. But if you plug in 1 times 4 is 4 minus 1 is 3. There's your first term. And if you plug in, well, you don't even have to really check if you understand that there's 5, but just to make sure that you understand the big picture, 5 times 4 is 20. 20 minus 1 is 19. That would be your last term. And since these are all increasing by 4, we see that increase of 4 there. We are good to go. That is accurate. All of these are increasing by 4. So that by itself should say that at least they're all in the discussion. The fact that this one starts at 0, you plug in 0, wipes it out to become a 3. There's your starting amount. That's good. 4 times 4 is 16, plus 3 is 19. This is also a possibility. So really, at this point here, you're checking to see if the initial value works and the last value works. If they both work, we're in business. Plug that in at 16. 16 minus 13 is 3. Plug that in, it's 32. 32 minus 13 is 19. So we're looking like they're all working here, but we shouldn't jump to conclusions because even though you plug in 2, 8 minus 5 is 3. 7 times 4 is 28. 28 minus 5 is 23, not 1. If that were a 6, then we'd be 100% across the board. You might say, well, wait, there's 5 between there. Well, look at the rest. There's actually, if you subtract, there's only 4 in between, but you're including both, which is why there's 5. So this seems like 5, but it's 1 too many.